everybody. So welcome to the production panel. My name is Eric. I lead the product team here at Modular. We've got an amazing panel for you all today. The goal of the production panel is to have an in-depth conversation about what it means to productionize AI, especially within today's Gen AI LLM world. But I'm not the expert here, so what we'd like to do is invite all our panelists up to the stage right now. What? Hey, Karen. Nice to meet you. Kelsey, Broughton, and Vivek. So we're really excited because we've got panelists from pretty much every part of the ecosystem. Carrie's from the compute side of the world. Do you want to introduce yourself?
Hello, my name is Carrie Brisky. I head up software product management at NVIDIA.
Cool. Kelsey is more from the applied side, and she also was, well, I don't want to steal your intro. So
Sure, yeah. I am Kelsey, co-founder at Adept. We are building an AI teammate for knowledge workers using an in-house multimodal model we built from scratch. Prior to this, I led productionization for large models at Google and had the privilege of working with Eric.
Broughton from the cloud side, obviously.
I run AI and machine learning services at AWS, and prior to that was at NVIDIA, running software infrastructure.
Cool. And then Vivek, both from the applied side and now data as well.
Hi, my name is Vivek. I oversee the ML and AI efforts at Snowflake. Prior to that, I started and sold a company called Neva to Snowflake, and Neva was a search engine that was using AI to give you answers, not ads.
Cool. So what we've got planned for everybody, we're going to do about, I'd say about 40 minutes of sort of prepared questions. And then we've got a couple mics here, one on this side and one on that side, that we'd like to invite folks in the last 10 minutes to come up and ask any questions they'd like of the panelists. Please, no hard questions. All right, so let's jump right in. This one's actually for Broughton. So AWS works with the largest enterprises in the world on cloud, many of those pushing the latest innovations to their customers. What are the most important AI production use cases today?
So we have a ton of use cases that our customers are using on AWS, and given that more customers do AI and machine learning on AWS, there's a broad set of use cases. That said, and we are seeing a lot of uptake of generative AI use cases now. I think when you go at it from the generative AI perspective, there's a lot of generative AI in software, software generation, code generation, testing, and so on. A lot of it in enterprise productivity. That's where we had Amazon Q, but how do you access company data? How do you query company data? How do you, interact with it? We are also seeing a lot of many different verticals, finance, software, media, healthcare, government, all of them going in. We are also seeing a lot in like contact centers, document processing, personalization, just computer vision, images, videos, and so on. So across the board, it's a really wide spectrum of use cases now.
Yeah.
I'm happy to kind of chime in. On the enterprise side, the biggest thing we see is customers want to extract, insights from their data, right? So they do all this work to get their data into Snowflake, to process it, to kind of organize it. But what they really want to do is to be able to talk to it. Like they don't want to talk to an analyst and ask them to produce a view or a dashboard. They just want to talk to their data. So things like SQL generation are super important for us. That stuff tends to be easy in the literature. Like you go look, you see a problem like Spider, but in practice, people have tens of thousands of tables, like hundreds of thousands of columns, and the precision requirements are super high, right? So that tends to be problem one. Problem two, I think what Broughton said, we see lots of talk to your, internal corpus, pick whatever corpus you want. Maybe it's FAQs, maybe it's customer support information. And the third thing we expect to see is, on the workflow side, and I'd love to hear Kelsey's thoughts there. We see lots of, if you have models that can call APIs and process responses from APIs, we see lots of use cases potentially showing up. The tech there is still some ways away.
Cool. So you mentioned Gen AI, obviously. These models are massive. Kelsey, one thing I wanted to ask you is, AI has long been about training models from scratch, right? And I think Gen AI, larger LLMs, foundation models kind of change that paradigm a bit. Do you want to talk a little bit about how you think especially from your experience at Google and Adept, that this is changing the AI landscape?
Totally. I mean, I think it's changing everything in a really exciting way. I think back to when I was first exposed to this at Google, this was a few years ago, and we started to see this complete shift in how teams were developing ML solutions for their production needs. So as you mentioned, Eric, rather than starting by collecting a bunch of data and building a model and really kind of handcrafting it and optimizing it for one particular task, all of a sudden, I think as Jeff Dean put it at the time, you're starting with the most capable model at Google and then using that as the foundation for any particular use case that you wanted to go deploy. And I think if I zoom out a little bit, implications of that on the industry are a couple of things that sort of counteract each other in some ways. I think one is it allows for many, many more folks to gain access to this level of capability that is quite new. And so as long as you have some data for fine tuning or the ability to use off-the-shelf solutions or open source models, you can really tap into this capability that's unlike anything we've ever seen before. And you don't need to have a really specialized team in order to go do that. So that's really exciting. It also means that developing these foundation models becomes much more challenging and complex and nuanced. And so you sort of see it becoming more accessible and less accessible kind of at the same time in different ways. But in particular, I think one result of that I'm really excited about, kind of building off what you two said, is when we spend time with customers, one of the things we're hearing a lot is for folks who initially maybe started with some use cases that are kind of more common in what you're seeing as those initial enterprise adoption of Gen AI use cases, whether it's code generation or copy generation, summarization, retrieval, are now starting to see what AI can do to a huge scope of workflows that they may not have ever considered applying AI to in the past, which is really exciting, whether it's claims processing and insurance, whether it's supply chain operations for logistics. They're really taking AI to like the heart of their business. And that's something that I think is only possible because of the capabilities that we're seeing today.
Yeah. Carrie, what do you
Yeah,
say?
I would jump in to say I think that the base foundational models have enabled two things. One is that, yes, these off-the-shelf foundation models are great, but no matter how accurate they get, there's still the need for confidential or secure or domain proprietary models for enterprises to be able to build off of their data and keep that secure. And so then that's the number one thing. And then number two is this shift of who's using them. So I think there was ML ops before where you had data scientists that were working more in the upfront of what kind of models or what's the best model, versus now it's more on the application builders where there's already a great model. How do I take that and actually apply it to my software and into my domain? And so that's where LLM ops has come in. So it's just this kind of a shift of the user a bit too.
Broughton and Vivek, do you guys want to add anything?
Can you repeat the thing?
Oh, the question was just earlier about, do you want to add anything to that kind of talk?
No, I think the one thing that I would add is what customers are doing is there's one aspect around how do I embed and retrofit AI, Gen AI into what I'm doing. And then there's a second aspect around how do I completely rethink how things work. And I'll give you an example, and I'm going to use a healthcare example because it's often perceived to be harder to do that. So today, when you go to when a patient goes to a physician, that entire patient-physician interaction has to be scribed manually. So there's someone sitting there and scribing it. And doctors today end up spending almost 40% of the time in this kind of manual work. That's time that's not being spent on patient care. And so now with generative AI, we have a product, Health Scribe, but we have a number of customers, 3M, NetSmart, and the others, who are now using it to automatically analyze that conversation and then generate automatically the clinical summary that can be uploaded to electronic health records. Now imagine, and that saves about 70% of that work. So imagine doing that for all the physicians in the US. And that's just rethinking, how you do the work. There's of course the work that, Kelsey mentioned, claims processing, document processing, mortgage processing. Today, a mortgage document can have almost 500 pages, that mortgage loan package, And customers, they spend 2 weeks just getting the required information out of that, And all of that is being completely automated. We had Anthem, who have automated 80% of the claims processing using these tools. So it's really getting embedded into all of these enterprise workflows, and we think that in the fullness of time, this will become part of every enterprise, every workflow, and it'll just transform the way we work.
Yeah. Vivek, did you want to add anything?
I think the thing I'd add is, and if there's one thing I'd have us all internalize, is traditionally we are like, this is a crowd of ML engineers, data scientists. But the thing we're seeing a lot is fine-tuning and in general personalizing and a foundation model to your use case, whether it's through retrieval or fine-tuning. It gets a whole bunch of people who traditionally never actually working with tech. Like we see people in the sales teams, people in sales enablement teams, all come out of the woodworks, tell us, hey, I built this cool demo on GPT-4, now help me productionize it, right? And I think that's happening across the board. You're seeing pull, you're not seeing, the buyer is not like, the person in IT trying to like deploy something, or the data science chief data officer. The buyer is like everyone, right? And to me, that's very powerful. That suddenly, Snowflake sees a lot more of it because our users tend to be analysts and business users, so we tend to see a lot more of it. But that to me is really like the technological capability where you can potentially just take a table of prompts and responses and with maybe 15 minutes of work, have a fine-tuned model that kind of somewhat works. But then on the other side, people who are very motivated to have these use cases actually deliver business value, that combination feels killer.
We had a really, Vivek's thing reminded me, we had a really interesting, use case of a big financial company that provides investment advice. And what they want to do is now say, look, I want to make these capabilities available to all of my investment advisors, investment analysts, so that when they're talking to someone, they can basically ask a question like, can you summarize the conversations that I've had with them before or with similar profiles before? So you have to do some kind of customization of the model. So I know what are the things that resonate with this customer, So it's kind of getting, I think Kelsey, you were mentioning this. At one level, it's democratizing access to all these AI and machine learning in a way that wasn't possible before.
So I think we've talked a lot about how awesome generative AI and large LLMs are going to be. But can we talk a little bit about how challenging they are to productionize? I think they stress the infrastructure in a different way than traditional AI sort of has. And so wondering whether, Kelsey, maybe you could speak to your experience at Adept and what it's been like to sort of have to actually productionize and send this large action transformer that you guys have to the world.
Yeah, definitely. Productionization challenges, there are so many. And I think back to when we were first doing this at Google, when we had LLMs, it was kind of only language at the time that we were playing around with, and setting up the first pipelines where any team could fine-tune a model and run inference on it and distill it down to something smaller, and everything that's required to get one of these things into production obviously varies a lot depending on the use case. For us, the thing that we hear most commonly from our customers today when they're thinking about use cases that they want to be able to deploy, whether it's with Adept or with other solutions, is latency begins to become quite the topic of conversation, particularly when you're using models that go beyond just text and are incorporating image data. At Adept, we build multimodal models that not only read the text representation of a web page or piece of software, but also read the pixels directly. And so it's quite important for us as we think about deployment to make sure that latency is something we keep in mind. And so for us, what this has meant is gearing towards more kind of purpose-built models for particular tasks. In our case, what we're finding is we can get surprising bang for buck from models that are a little bit smaller if we're really thoughtful about training data and how we develop those models. And we're hearing from customers that they're finding more success with those types of models than in certain use cases what they're finding with just throwing like the biggest, most general model possible at a given task because of those latency constraints. So I expect we'll see a lot of innovation to come in this space because of the need on the customer side, but that's something we're hearing a lot from both customers and prospective customers right now.
I would say that I agree with everything that you said. I also think that our customers are really worried about hallucination. And then how accurate is my model? So evaluation. How do I evaluate my model? So they might have started a POC with an off-the-shelf model that's maybe expensive or is 175 billion parameters, and now they're trying to use an 8 billion parameter model, and they're like, it's not the same accuracy, even with some customization. And so doing those evaluation and trade-offs can be a little bit time-consuming, but you have to kind of speak to experts of, can I use something that's a mid-range model and still get higher accuracy, but that increases my compute footprint. So it's accuracy, latency, and then the compute footprint. I'd say that's the trade-offs that they're
I agree
concerned
with
about.
that. When customers are looking at deploying this at scale, then there is the accuracy aspect, of course, but, latency is important. Cost becomes really important. What's the cost profile at which I need to fit in? And then it becomes a multidimensional optimization problem. And then when you start optimizing it, you suddenly realize that, one model isn't going to cut it for all different use cases. You need multiple models, and that's what Kari and Kelsey were saying. And then you also need pretty specialized capabilities in the infrastructure that you did not see before. So I'll give you, a couple of examples. So when you're doing training, let's say pre-generative AI, pre-LLM model, pre-LLM era, customers would take like small scale clusters, maybe 8 nodes, maybe 16 nodes, maybe 32 nodes, and they're training it for a week, for a couple of weeks. At that scale, the probability of having faults is very, very low. When you think of generative AI and you suddenly get to tens of thousands of nodes where you're training for months on end, the probability of faults is very high. And so at a software infrastructure level, you now have to think of resiliency and how do you self-heal the clusters and so on. Kelsey was also talking about inference costs. That's huge for our customers. And so what many customers would want to do is, previously they would say, I take an instance and I allocate a model to it. That means your instance may be underutilized. And so what customers do now is say, I'm going to put multiple models on a single instance, but then you end up in a situation where one model could be processing images, another could be generating like a 5-page text, a third model could just be generating a 3-word summary. And then how do you now do intelligent routing? Because every model has very different resource needs. So there's really very different dimensions and different problems that you now have to address as you're thinking of the scale that customers are using now.
And are you guys building anything at AWS to make that easier? Or how does
that is what we're doing. So, for example, if you look at our infrastructure, the software infrastructure, which is SageMaker, we now provide automatic self-healing clusters. So, you'll checkpoint the application from time to time, and then if a node goes wrong, you're going to bring a new node in. On the inference one also, we have now done intelligent load-aware routing. So, you look at the load for different instances. Then we allow multiple models to be packed into a single instance. So, all of these are stuff that we are adding in. And, I'm pretty sure that's also where we can use Modular to actually take this to the new level as well. But, you really have to, this is a new world in terms of the scale and the complexity. And so it's kind of top to bottom. You want to have purpose-built capabilities in the infrastructure. Often, or not often, in many times, you will see that one model isn't going to do it. The largest model isn't going to do it. So you often need models that are actually specialized to what you're doing. And then similar in the applications where you really have to tune your application, often tune it on the data, make sure that you're taking care of, all the privacy and the security issues. So it's really a pretty complete rethink of how we work.
I was going to add in the software too, just not just the hardware. So some of our customers have, I think there's been some really good research in tactics and techniques that have come out with parameter efficient fine tuning and adapters. We have customers that have 300 adaptive layers, so you can still have that larger model, but then just serve the adaptive part of the weights changed in the model. So you can do that through inference solutions. So there's ways of getting around it where you don't have to have multiple models of multiple foundation models, but one foundation model, and you're just serving smaller pieces. So I think there's a lot of innovation happening to make it more useful.
This brings to mind, I was just chatting with one of our infrastructure engineers on Friday who was like, yeah, I'm working on the quote unquote boring stuff, like just making it possible to train these models, but nothing is boring at this scale. So things that sound trivial when you're working with 8 nodes, as you were saying, all of a sudden when you're scaling up, everything becomes a lot more interesting.
How does this, I think we talk a lot about training within Gen AI. We've also been mentioning that we're going to end up with a lot of task-specific models. How does sort of the training inference split look in a Gen AI world or like an LLM world?
Once you have, initially there's a lot of training, right? Yeah. And training, fine-tuning, retraining, and so on. And that's the experimentation phase. But once you've deployed into production, then the inference phase kicks in because, it's running all the time. You're running millions, billions, trillions of inferences. So there will be, as you're thinking of a particular application or a particular use case, there is a situation at the front end which is a lot more training heavy. And then as you deploy it into production, the inference parts takes over.
I would actually counter that because I would say that especially with generative AI and you're doing reinforcement learning through human feedback, that feedback loop is tighter. So once whatever we're learning in inference or feedback from the use cases gets fed right back into a new model. And so we're training at least 5 models a week or fine tuning on top of that foundational model 5 times a week just to get the feedback from the reinforcement.
So sort of like a continuous learning loop.
Yeah. I would actually kind of change the question a bit.
Yeah.
I'd say rather than training and inference, it's what is the R&D stuff and what is COGS, right?
Yeah.
At the end of the day, like we're building these models so we can actually get use cases out there that customers will pay for. So whether it's the fine-tuned use cases or the inference use cases, it's hopefully a place where you can make them COGS. The base layer I don't expect is COGS. That's going to be like R&D costs. What we are seeing very much is a world where, the last 2 years, maybe last 12 months even, there's more work in the inference side than we've ever seen, right? Across the board, like this room here, a whole bunch of other people, whether it's at the lowest layers, like more efficient kernels, better programming languages, layers above it, whether it's scheduling or like page retention or whatever. And then stuff that I think people are not paying as much attention to yet, but more lossy techniques, whether it's speculative decoding or distillation or quantization and compression. So we expect inference will keep kind of pushing the cost of inference down, but I think what people end up doing is just more inference. To give you an example, when we were doing Neva, so Neva was a search engine. We used to do almost 300 inferences on every user query, right? And this was across retrieval, ranking, so those are kind of smaller models. Retrieval is like maybe 100 million parameters. Ranking is maybe 1 billion parameters, and then generation, search typically for those of you who work in the search system, 200 to 400 milliseconds, 99 is what people want. So maybe we were doing like high single digit generation and then streaming. And just where we started and where we ended in 3 months was like 20x. So, and it was not because of anything we were doing, it was because of like stuff everyone here on the panel and otherwise we're doing, just being able to build on those things. So I think the arc that you can bet on as inference is going to become more and more efficient over time. But it's going to be where all the compute is. And I say inference, when I say inference, I include, any RLHF or any.
Right.
I think what'll be interesting too is not only in the direct sense where if you're doing RLHF, for instance, where you're continuing to train the model as it's being used, but as both you see continuous innovation happening on the training side, where it feels like every day there's a new technique or paper or interesting insight that we get that gives us ideas of what we want to do, but also at least what we're finding is our best modeling ideas and research kind of fodder comes from playing with the models we've already built. And so as we run more and more inference, whether it's with customers or even just internally playing around with what we've built, that's how we get the best ideas for how to improve. And so it's like more inference directly leads for us to more R&D or more training because we get ideas on how we can make the models better. And so it becomes this kind of virtuous cycle as well.
And just to build on what you said, using these big models to generate labels is often like a bootstrap that people will use often, with the tiny stories models or the 1.52 models. That's often a technique people use. So we end up reusing our own inference systems a lot for training needs as well.
Mm-hmm.
So we've been talking a lot about models. Maybe I want to stick with Vivek on this one. We talked to a lot of customers that say, hey, look, the model is really, really important, but I also have a tremendous amount of latency and cost in my data pipeline. Can you talk a little bit about what you guys are doing in Snowflake to help with that problem, or what you're seeing at least?
Yeah, this is the perfect Snowflake question, right? I think if I have to summarize it, we do nothing on top of what Snowflake already does, right? But Snowflake does a lot of things, and our customers love Snowflake for all the things it does. Snowflake has a huge data engineering investment, whether it's proprietary storage formats that you ingest your data into. You can point it at an Iceberg table, and that'll work as well. And then we have things like Snowpark, which are ways to run Spark-like workloads on our custom warehouse runtime. or you can do streaming and tasks, and that lets you build streaming pipelines. And we have things like dynamic tables that make it very easy for you to kind of maintain a materialized view in a streaming fashion, right? So all of that investment our customers already use, and if you have customers that use Snowflake, are likely using them already. And so our approach to what should we do for AI data pipelines is let's do nothing that is not already built. Like, it makes no sense for us to go do a lot of extra work. So for example, if we want you to do inference, the way we'd see that work is all your data would have been ingested into some tables, and you'll just say complete, like you would say max or average, you'd say complete, you'd point at that table and you're done, or some column and you're done, right? You'd prompt it with the column value as one of the things in the prompt. If you want to do fine tuning, you just point at a table with prompts and responses, and you'd say, now fine tune this model, and a couple hours later in your customer account, you should have a fine tuned model, and then you can just reference it as a model object and just do inference on it. If you want to do retrieval augmented generation, you should just be able to have a native vector data type that just converts a particular text column into vectors. And if you want to build that kind of chatbots that Breton talked about, you should just be able to say, create search service, here's a bunch of columns, and it just works. And so, that's a very nice way to decouple what is an area where, customers spend 80% of their time, but they spend 80% of their time on that already. So let's not have them spend another 80% of their time on this stuff, and just have them start using generative AI. And this stuff actually, from our perspective, as trivial as it may sound, it actually helps customers take the leap from prototypes to production use cases. Like, we had this customer, they were exporting the data into AWS, they were bringing up some inference service, they were running inference, they were ingesting the data back in. They're of course doing multiple hops through their CISO, their privacy, their legal, their compliance teams to do all this stuff, because those teams all get very stressed out when they do this stuff. Now it's just one line of code. It never leaves Snowflake. It just works. So that's kind of the direction we're taking.
Yeah. Broughton, how do you guys?
So there's all the stuff on the structured data that I was talking about. There's also all of the unstructured data, text, images, and so on. And then so data labeling becomes important. And in many cases there is sensitive data and privacy and security. So then you need a specialized workforce, and you need to have the right workflow so that all of that data curation, data labeling is done in a secure way. Then everything around responsible AI becomes really important. Have you really vetted it for bias and other toxic content? So that whole data pipeline, it still remains a garbage in, garbage out process, machine learning. And so I think sometimes we get caught up in those models and how big they are and so on and so forth. But unless you're doing everything on the front end in terms of the data cleansing and data prep, the results aren't going to be there. Yeah. And, we are increasingly seeing multimodal use cases. So in that situation, you're taking maybe some tabular data, maybe some text, maybe some images, and so on. So, being able to do data prep across that entire spectrum is important.
Yeah.
I was just going to add that sometimes even using large language models to help with your data, whether classifiers of personal information you need to take out. NVIDIA, we're great at acceleration libraries, so accelerating things like deduplication. If you think about all your data and how many times it's actually duplicated, and when you're training, you're either wasting compute on duplicative data, and it actually doesn't improve the accuracy of your model. So being able to understand your data and remove that duplicate data and do it in a fast, accelerated way. So we offer obviously tools and libraries, and then using the LLMs on top of your data is important.
And there's also capabilities like querying the data to get the right amount of data. You might have done some training and then you realize, well, I need to train this a little bit more in these scenarios. And so then being able to query and say, hey, give me these kinds of images so that I can go and retrain the model. So it was a necessary and critical ingredient for machine learning and AI. It continues to remain a necessary and critical ingredient with its own requirements and its own pipeline.
Carrie, this one's directed at you. So compute is such a critical part of the AI ecosystem. What is NVIDIA doing to make it easier to develop and deploy on the compute side? What are the hardware architectures that are coming out? How do you look at the software? You have to program the hardware as well. So how do you look at the software side of that? What's changing on compute to make all this possible?
Well, I mean, NVIDIA is obviously always innovating and coming out with new architectures, but I would say that we're not just a chip accelerator. It's about the full data center. I mean, we're a data center company, right? So it's about, I think, Breton, you said, you're talking thousands of GPUs. So it's the GPU, the systems, the networking, the communication, thermal cooling architectures. So, I mean, it's not just one accelerator, it's about how the whole thing works together.
Yep.
And then the software to be able to scale to tens of thousands of GPUs and do checkpoint restarts and things like that. So, I think we hear the word end-to-end a lot, but NVIDIA is an end-to-end computing platform, so everything from the model and how it goes across the entire data center system.
Gotcha. Broughton, you guys are investing in a lot of silicon as well. Can you talk to us a little bit about what problems those are, I think Inferentia, Trainium, Graviton, obviously. Yeah.
First, we are very close partners with NVIDIA, and our P5 instances, they're meant for training, G5 instances for inference. Last year at reInvent, Adam Selipsky and Jensen announced new partnerships, and we are very close partners, and we love working together with NVIDIA. Now, customers also want choice, and so we have Inferentia, which is purpose-built for inference of generative AI models. We have Trainium, that's again purpose-built for training of these models. We have many customers using it. They love the cost performance that we see. And then, as Kari was saying, it's not just about the chips, it's also about everything else, the networking. So we have EFA networking to provide you much better performance. So the networking, the bandwidth, and then also a lot of the software optimizations that go in. So for example, when you're training these models, it's really important to be able to kind of overlap the compute and the communication, as you're sending weights and parameters, all that. So there's just a ton of work we are doing at every layer. There's the partnership with NVIDIA, there's a custom purpose-built chips, processors for generative AI, AWS Trainium, AWS Inferentia, everything else around the networking and just the data center architecture, and then all of the software smarts that we add in.
Yeah. Did you want to add something, Vivek? Or?
Oh, just get me more GPUs.
Cool. One of the interesting things we talk a lot about in AI infrastructure is research to production. You hear that a tremendous amount. Just want to kind of open it up to any of y'all to kind of talk to you. How are you seeing customers today streamlining that process? Because I don't think it's, we look at Modular as a very difficult process today, but would love to hear in practice what you guys are seeing.
Yeah, happy to start here and curious to hear from others as well. This is something that is very central to what we think about at Adept. And I think in many settings, the research to production flow looks something like research develops something sort of in a silo and gets to this really interesting discovery, and then they sort of like lob it over the wall, and the product people catch it and are like, okay, what should we do with this? How do we get this into production? How do we apply it to a specific use case? I think over time, this is getting a lot better. I think that was kind of the traditional way of doing ML research. If you think about, like 5 or 10 years ago, I think that was very much the paradigm. And I think we're seeing this improve over time because a lot of the potential with these models is in applications and seeing what you can actually enable for users and for businesses, which is really exciting. One of the things that got us really excited when we were starting Adept is the opportunity to bring those two worlds together really from the beginning, and to be able to have really breakthrough cutting edge research, but done in the service of users and specific use cases and customers. And so for us, what has been really exciting is being able to take a particular use case for a customer, put together a team that spans across the whole gambit. We've got research and infra and engineering and product and everybody in design, this like very cross-functional team working together to go solve this one task. And so I'm hopeful that we'll see more and more of that in the industry. And I think we're definitely headed in that direction, where it's not just research happening sort of like off in a corner, and then production happening off in this corner, and then trying to like build that bridge, but actually more of this happening like in tandem and jointly to attack some of these use cases together.
I think the pre-trained foundational models have helped that a lot too, bridge that gap, because I would say 5 years ago, there are very large companies who employ hundreds of people who are just optimizing engineers to eke out, like 3% more out of that model, either in latency, throughput, or accuracy. And now, people don't have that time. They want the time to market to be much closer. The second model comes out, you need to be able to see the return on investment. And so I think that the tools are getting better, right? So there's standardized optimization paths between either that training framework or the inference compiler, or bringing them even closer together so it's the same one in both instances. So I could talk about this for hours, but those are the big things that I've seen, the pre-trained models and then the software that has gotten better to reduce that time to market.
Many of our customers, when they're operating machine learning at scale in general, there are few Gen AI models that they're starting with, many more classical models that they're already doing for like some forecasting and so on, a lot of deep learning models that they might be doing for recommendations and so on. And so there is, when you think of the whole end-to-end thing, like, it's not just one or two models, but my entire machine learning operations, right? One of the things customers say is, look, I want to be able to use it on a single tool. Like, I don't want to go to this tool for this Gen AI models, this tool for imaging models. I want to have a complete thing. And that is really important for like governance and auditability requirements. So all of that comes in governance, auditability, and so on. Do you provide a comprehensive platform that supports all of that? Do you provide lineage? Do you provide traceability? All of that gets really important. And then, we mentioned ML ops or LLM ops, that gets really important. Are your workflows repeatable and scalable? How much have you automated them through pipelines and so on? That becomes really important. I think, this is an important problem. Now, one of the very interesting cases we have seen with machine learning, and, folks at Amazon have written some papers about it, that's kind of maybe a little dissimilar or more challenging than what you see with typical software development, is that when you're taking something into production in software, you have this notion of backward compatibility. When you now take a model and put it into production, is it really going to give you the same results on every single use case that it has been subject to? That can often not be the case, and that introduces new issues into when do I deploy it and how do I make sure that my existing customers who are using it don't get unexpected results. So, there's that entire gamut of hardening things. Then there is this new set of things that come in. And then there is the whole thing around, governance and auditability and so on, lineage, traceability, the whole thing. And then there is like, I just don't have one model in production. Like our customers have tens of thousands of models in production. Some of them have hundreds of thousands of models in production, right? And so then how do I have a converged place where I'm seeing all this, a single dashboard, and how do I make the whole thing work?
Yeah. I mean, organizationally, we do what Kelsey does. It's a single organization. They're completely integrated. We have no tolerance for, silos that will lob stuff over the wall. Everybody is accountable to each other. It's a single team. We hold our researchers as accountable as our software engineers and our production folks. This is kind of the model Google used to use like 10 years ago. And then they switched to this model where the researchers are writing more publications and then lobbing stuff over the wall. But in the pre-deep learning era, this is exactly what they were doing to kind of get applied ML out the door. They were doing things like continuous training back in 2005, right? Which is insane. And you'll do that only if you're like integrated. You won't do that if you're like, writing papers and lobbing stuff over the wall. You'll never discover that use case. You'll never discover you have 20% wins from doing continuous training or whatever. So we are very much, everyone sits in a room together, everyone plans together. Sure, the research teams have a slightly longer roadmap, but they're as accountable as anyone else.
Yeah, just quickly building off of what Vivek was saying as well, it's really cool when you have these teams working together, what comes out of that interaction that might not have come out of these teams working separately. I mean, even if I think about not just bringing models to production, but how having research and engineering or production teams together has informed the way we do product development overall. It's like if the typical sort of product development cycle is, you spend time with users, identify a use case, build a solution, and then kind of validate it and improve it over and over. Research kind of feeds in at least two main ways from what we find. There's user research and the product development process influencing research. So saying, hey, we've used this models, or our customer has this problem. I wonder how we might solve it. There might not be a solution today, but I wonder if through these combination of research techniques we could get there. And then also the reverse, where new capabilities that our research teams are developing also inspire new use cases and demos and things we might be able to do on the product side. And so it's not just about making that kind of research to production flow faster and easier, but it also means that we get net new things that we might not have had if these teams were operating more separately.
Yeah, I couldn't agree more. I think sometimes the product makes the research problem easier.
Yeah.
Because you could get your users to do stuff for you that, your researchers would benefit greatly from, like just the simple data loops you can get going are the most trivial version of this. When I was in grad school, there's an analog, there's this whole system, and there's this whole branch of computer science called hard real-time systems, which builds systems with how do you make sure if you have tasks with hard deadlines, they all get scheduled. And that whole area started because the control theorists didn't know how to deal with adaptive delays in their system. But in the 20 years, the control theorists figured that stuff out, right? And so there's this whole set of branches that barely talk to each other that if they talk to each other, you potentially could avoid lots of work. And so we see that all the time in our world.
And I think we originally started off talking about sort of unifying infrastructure across research and production there, and then we ended with unifying the organization. But I think these things also go in tandem as well, right? I think a lot of things we see at Modular are separated research organizations make their own decisions on tools, and then you have your production team making a different decision on tools, and that's where you get a lot of this sort of bringing actual research to production. That's where you get a lot of issues. Just since I have all you guys here, what would you say the average amount of time is to go from research to production with a new innovation? I'm going to put you guys in the spot a little bit.
We have very fast product development cycles. I mean, I agree with everything that, Vijay, Paris, and Kelsey said. And it's like a single Scrum team, which has product managers, researchers, UX, engineers, and so on and so forth. It depends on the complexity of the feature. Some things we can get out in a matter of weeks, if not sooner. Some things can take a couple of months. It really depends on the complexity of the feature. But I think the key underlying theme of, that fast iteration, and that has gotten faster, and you've got to focus on making it faster and getting people together. I think that point is very valid.
Yeah.
I'll just jump in. I think Brian was up here speaking earlier, and so we work really closely with his research team. And so when you're planning something like a pre-trained foundation model, that can take months to train. But then it's really important that you, as I mentioned, getting that return on investment. So we work step by step that the second that it's done training, we're doing the evaluations and then getting that out to the customer. So I think that our latest round of foundation models, we had it out within 3 months and then getting into production with the customer. So I think that was, we call it speed of light. What is our speed of light? What is the absolute shortest amount of time that we can get something done and out the door?
Well. All right, that's all the prepared questions I have. Exactly 10 minutes.
Way to go.
So we'd love to just invite anybody down to the mics to ask these awesome experts a question. Just jump right up to the mics.
Let's see. Okay. Hello. Thank you for joining us here. Appreciate your time. Beautiful con. Always beautiful to see a very first con of a company. I'll cut right down to ML engineer, San Diego, do a little bit of consulting. I want to ask you about synthetic data. So obviously, a lot of the companies right now are kept afloat by the legal ambiguity and obscurity of how and what they train their data on. It's also sometimes not as good. Real data is messy. And for a lot of pre-training, we can probably use just synthetic data, right? And just reduce the problem to just fine-tuning, get rid of the lawyers, get rid of a lot of our problems. So there's exciting stuff that NVIDIA is doing in that regard, like let's model everything, let's create a fake universe. There's all the cool stuff coming out of research, like I know Microsoft Research did a very cool thing on facial recognition. They just trained on 3D models, right? And then just got way better performance because your 3D models are perfectly labeled. I'm just giving some context, right? So this is synthetic data. What, kind of a general question for the panel, no one in particular. What do you see as the role of synthetic data? How is it impacting what you're paying attention to? Are we still in a space where it's a zoo of tools? Are we convergent towards something like where maybe one day, Modular has an API for synthetic data, and it's like, okay, just like plug it in. The developer, you can totally not have any legal involved to do all the pre-training and just be more productive. So I know it's a big kind of wide question, and I don't expect a razor-sharp answer, but hopefully it's an interesting topic. Thank you.
I thought it was a great question. I mean, I'll just jump in really quickly. I think that if you've ever heard our CEO Jensen speak, just the other day he was talking about how he himself, as humans, we all do, we use synthetic data to train ourselves. If you think about before you go onto a speaking event, you might role play it in your head 100 times before you actually get on and get out there. And so we use synthetic data in our dreams, ourselves to impact the way that we behave. And so I think that synthetic data is just as important to neural networks. And not just training data for pre-training data, but also even in retrieval systems, because you need to create synthetic data if you have all this corpus of data, but you don't have the instructions behind it or the questions and the answers, and also being able to judge. So I think it's really important. Will there be one API? I mean, I don't know. I think that because data is as unique as the use case and the industry that it's in. But I do think that there's a lot of really interesting stuff, and I would also encourage everyone to check the licenses of open source models, because there are many restrictions on using those large language models for synthetic data generation. So try and find the models that actually allow you to do that.
Yeah, I'd throw four things out there. LLMs as judge, absolutely use it, right? LLMs to generate training data, kind of use it, but be very careful, both from the license perspective, but also just feedback loops. And then two other things that you kind of threw out there on the quality of the raw data itself. I do think there's an opportunity, and someone will like seize upon it to create kind of a, at YouTube as an example, right? Creators get paid rev share. They create content, they get paid rev share. I think as we go to this world where publishers don't get clicks from like search engines and their data is being used for stuff, right? I expect there will be a world where there will be a licensed data set of public data people can, and the value that data set will have is, yes, it's licensed, but B, it's also free of like, bad data or data generated by bad LLMs that happens to be now in the broader web pool and things like that. So I think there is an opportunity there. I think like just as fast as the modeling space is moving, I think the data space will end up there.
Thank you.
Thank you.
Hi, I'm Jason Mars from Michigan. Thank you guys so much. It's been a very, very illuminating panel so far. So one of the things that was mentioned was it seems like every day there's 5 new techniques, whether it's in what we put in front of the model for prompt engineering or some kind of fine-tuning approach or methodology. I was curious, in this sea, it's hard to know what to pay attention to or what trends might be predictive of the techniques that will dominate in the future. I was just wondering from your guys' perspective, what recently has excited you in that space? What do you think might actually be an interesting new methodology, whether it comes to RAG or whether it comes to a LoRa type technique or anything in that realm that you've seen that maybe we all should be paying attention to?
I think you nailed it with LoRa. Because that's something that's very much research and just now pulling that through to production use cases. Like I'd say enterprises either didn't know to ask for LoRa, and to the point where now we do have enterprises that come to headquarters and are asking for it. So I think that feedback loop, again, of going research to production to enterprise use cases is tightening. But I think that, like I said earlier, I think that's parameter efficient fine tuning, LoRa, adapters, like all of these ways of being able to be more efficient, but still utilize the full, huge, large foundation model and personalize it to yourself, and then serve it is one of the most practical techniques that's coming out right now.
Yeah, apart from like a specific thing that's exciting, because it's frankly very difficult to choose among everything that's going on, I would say one thing that we have learned and sort of an approach that we take given the field is moving so quickly and there's always something new and it feels like every day or every week there's like a slew of things we want to try, is kind of a combination of really learning by building. We find the best way to really understand whether something's a good fit for our use cases to just try it. So we'll often have someone go off and just experiment with something for a day and see sort of what they come back with. And then also just taking inspiration from others. I think what's really great about this era of AI is not only are there new innovations in modeling techniques or infrastructure or whatever it might be, there's also so many people so excited to apply this to production use cases. And so often very quickly, as soon as something new is released, there's a bunch of folks talking about how they've tried this and what results they found. And so you can't possibly try everything. It's just not feasible. And so a combination of sort of trying things out and learning by building while also paying attention to what other folks are finding and putting some of these into practice is just a critical skill these days because of how fast the field is moving.
Definitely.
I can give you my two. My first is Q-Star.
Yeah, that's interesting.
And MOE models, more seriously. I think the research on that has all gone underground a bit, but there's still enough stuff showing up that it feels like a very promising direction.
There's a very wide spectrum. I think MOE is one of them. All of the distillation techniques are interesting. Bunch of stuff on parameter efficient fine-tuning is interesting. Anything around reasoning, logic, planning, and so on. There's just so much going on, as
Hard to choose.
Kelsey was saying. It's ultimately it is what is the use case, what is the customer problem you want to solve, and then starting from there and seeing what works best for you.
Thank you guys so much. Very helpful.
Thanks. We only have time for one more, unfortunately. So why don't we take it from this side of the room? Yeah.
Hello,
Apologies
Rakesh
to
here
others.
Rakesh here from AWS. So I have a very hardware-specific question. So I think AI is in a mode where we are in the age of the initial motor engine, where we have over a century improved the mileage of it. So in that sense, GPUs are built specifically for filling one pixel at a time, specifically. So it is great that we reuse them for AI, but I think they are not built for that purpose, right? So purpose-built hardware for training and inference is where I see the future is. So can you guys share information on how NVIDIA is approaching this, right? So we are still in this GPU mode, but I don't think so that is enough if we want to get to a better mileage, as an analogy, in terms of using inference and training. So what do you guys think about the hardware revolution?
Well, one, we're always innovating. We have many different SKUs of accelerators. So yes, we're a general purpose accelerated computing platform. Things like our Grace Hopper chip, where it's a CPU GPU combination for larger embeddings and recommendation engines. And so we have different SKUs even in AWS for they're specific to graphics that do graphics decode, but then you can still use those for AI, but we have specific AI chips as well. So I think that why are we trying to keep it general purpose? We are always focusing on the hardest problems. And so we're always building our next architecture focused on the hardest problem. And today it's generative AI. Previously it was deep recommendation engines before that, right? So, and then when you're using generative AI, I think putting it all together. So we're talking a lot about text and text, but there's multimodal, there's speech synthesis. So when you think about what is AI, it's human-computer interaction. And so using all those models together onto a specific device is something that we are always thinking about and always building for.
Right. Well, now concludes the panel. Unfortunately, we could go on like this, I think, for a long time. But can we just give the panel a round of applause? Thanks. All right. Thank you very much. Thanks, Kelsey. Broughton.